We've been studying earthquakes lately in our class, and so I thought we would do a little bit of a review about them. If you recall, every earthquake fault has a hanging wall, and this here is the hanging wall on this side. And in class we talked about how you can tell the difference, and the way that I have always been able to tell the difference was to look and see if you could have a little rope swing hanging down from the side. So here we have a little hanging wall. We could have a little, we can have a little person rappelling down. So I know that is the hanging wall right there. And then I also said that if you could kick it with your foot, if there was a little guy right here and he could stub his toe on it, then that would be called the foot wall. So I'm going to label this one the foot wall. So these are the three main types of faults. The fault on the top is called a normal fault. And the reason we can tell, or how we can tell it's a normal fault, is when the hanging wall moves down. So you could see there's a down arrow right there. Okay, so when the hanging wall moves down, it is called a normal fault. So when it's not the hanging wall slipping down, but it's the foot wall going down, it's called a reverse fault. It's pretty much the exact opposite of what a normal fault is. And this last one right here, it doesn't have like a foot wall or a hanging wall because they move like next to each other, or they're going in two different directions. And this one's called a strike slip fault. And this is the one that we know really well in California because of the San Andreas Fault. Earlier this year, we were talking about divergent, convergent faults. And so over here, you can see that this fault line and the normal fault is moving away from each other. And so we know that that is called a divergent fault. And it also has a specific kind of stress that's associated with it. And the stress that's associated with it is tension, because it's being pulled apart, kind of like a tug of war. And then if you look over here at the next one, it's moving together. And we talked about that as being called convergent because it's coming together. The type of stress that's at a reverse fault is called compression because you're compressing two things together. Lastly, at our strike slip fault, we have what's called shearing going on. That's the type of stress that goes on here. I always tell my students it's easiest to remember because it's like the three S's, as you see as I underline them right there. So here are some folds in the Earth's crust, and the folds have been created because of compression as the two plates are colliding. And we did talk about how to remember what the folds are called because scientists have given them a specific name. So we said that when you see a smiley face, so it's in the same area as a smiley face, it is called a syncline. And remember that it's easy to remember because syncline and smiley start with the same letter S. We also talked about how means an opposite, so an anticline means an unhappy face, or in this case it means the other type of fold. This is an anticline. So this really simple drawing right here, it shows you what happens when there are two normal faults running parallel. So what happens here is we've got tension because the plates are pulling, and then here we have this foot wall. It's a foot wall on both sides, and it's moving up relative to the hanging wall, which is moving down. And what's happening here is it's creating fault block mountains. It's a very specific type of mountain, and this is the type that happens in this area. You can find these in the Sierra Nevada, the Mojave Desert, a lot of Nevada and Utah as well.